Hello, students, boys and girls. I hope you all are enjoying your journey of metals and non-metals. Yes, you have learned about the physical properties of metals, chemical properties of metals, and we have also seen how the metals, they are reacting sometimes even, with the acids, then they are reacting with other bases also, and we've seen a number of chemical properties. Now we are going to see the second part of the topic, which is non-metals. So metals and non-metals. So in this topic, we are going to do all the physical and chemical properties of non-metals. So non-metals also have some chemical properties. So we'll be doing about the physical properties and then the chemical properties of non-metals, then non-metal oxides. What are they? Whether they're acidic in nature or basic in nature, just like the metal oxides. Yes. And then reaction of a metal with a non-metal. This is very, very important in this topic. And formation of ionic bonds. You'll be doing this ionic bond formation and the properties of ionic compounds. So, all set? Ready? So, let's go. Now, non-metals, the physical properties of non-metals. So, non-metals, they are bad conductors of electricity. They do not conduct electricity. Except, now here also again we have an exception, graphite. Graphite is a very good conductor of electricity. If you see in your pencil leads, you have this graphite. They're made up of graphite. Graphite is an allotropic form of carbon. Now this allotropy topic you will be doing in the chapter of carbon and compounds. Okay. So graphite is an allotropic form of carbon. Like you have done, allotropy, I remember that you had done in grade 8. You have done all about the amorphous forms, coke, charcoal, yes, anthracite. All these were the amorphous forms of carbon, but they were allotropic forms. Similarly, we'll be doing about diamond and graphite, which are the crystalline forms of carbon. So allotropic form of carbon, graphite is a good conductor of electricity. Remember, it is coming from carbon. It is an allotropic form of carbon. But carbon is a non-metal. And we are saying non-metals are bad conductors of heat and electricity. But exception here is graphite. Graphite is a good conductor of electricity. Then malleability and ductility, non-metals are brittle. They are generally in the powder state, or even if they are solid, with a slight, even with your fingers and all, you can make it into a powder. So like coal and all, if you see, if you hit it even lightly, you get the powder form. So they're very brittle, they break easily. Then melting and boiling points, non-metals have low melting and boiling points as compared to the metals. Then density, most of the non-metals have low density, whereas metals have high density. Okay. Then color, most of the non-metals have come in various colors. They have a number of colors. Okay, so these are a few physical properties. Then we will see about other physical properties. Now coming to the hardness, non-metals are soft. They're not as hard as the metal. They're generally soft, except, now here is the exception, diamond. Diamond, you all have seen diamond also, diamond jewelry. So diamond is the hardest naturally occurring substance. Now, again, this is an allotropic form of carbon. Allotropic form of carbon. One we had done graphite. Now it is diamond. So diamond is an exception. It is very, very, very hard. Otherwise, most of the non-metals are soft. Then state, what state do they exist in? Non-metals may be either solid or a liquid or a gas. Okay, they may be a solid, liquid or gas. Now, bromine. Here is an exception. Bromine is the only liquid non-metal. Liquid non-metal. Okay. bromine. So this is an exception. Otherwise, they exist either a solid or a liquid or a gas. Then luster is the shine. So non-metals, they do not have the shine like the metals. But again, exceptions are diamond. Of course, you all know about it. Diamond shines. And iodine. Iodine also shines. Symbol is I. Iodine, which is a non-metal, it shines. So these two are exceptions. Now these exceptions, CBSE might ask you as a question. So you should be able to answer them. Okay. Then sonority, yes, because they are very soft, they are brittle, then so obviously they will not produce the ringing sound. So they are not sonorous. They do not give that typical sound. Okay. So if you see here, there are many non-metals. They are all colored. This is phosphorus. Phosphorus can be yellow phosphorus, red phosphorus. This is sulfur, which is yellow. Then this is carbon. This is diamond. Okay, so this way you have many colors of the non-metals. Got it? Now let's see the chemical properties of non-metals. First one is reaction of non-metals with oxygen. So non-metal plus oxygen will form non-metallic oxide. They form their corresponding oxides. So carbon reacts with oxygen to form carbon dioxide, and a lot of heat is given out. This is what is this reaction known as? Yes, exothermic. So burning of carbon is an exothermic reaction. Carbon reacts with oxygen to form carbon dioxide. Now carbon also reacts in limited supply of oxygen. When the oxygen supply is limited, okay, it will form carbon monoxide. Heat is given out, carbon monoxide, and this carbon monoxide is very dangerous gas. It causes suffocation. Inhalation will cause suffocation. Okay, so it's very dangerous. And it gives out a lot of heat. Then we have sulfur. Sulfur reacts with oxygen to form sulfur dioxide. Okay, hydrogen reacts with oxygen. We are talking about oxygen here. Oxygen reacts and form water. Hydrogen, as of today also, hydrogen is placed with the metals in the periodic table, if you see the periodic table, but most of the properties are those of the non-metals. Okay, so they didn't know actually where to place hydrogen because of this reason. So these are the non-metallic oxides which are formed. Now let us see what happens when these non-metallic oxides are reacted with water or dissolved in water. Now here we are going to test whether these non-metallic oxides, we want to know whether they are acidic or basic. Okay, we want to know whether they are acidic or basic. Let us find out. How? When I dissolve carbon dioxide in water, it is forming carbonic acid. It forms carbonic acid. So CO2 plus H2O forms H2CO3. So this is an acid, carbonic acid. Similarly, SO2 plus H2O forms sulfurous acid, H2SO3. Then SO2 plus excess of oxygen will form another type of non-metallic oxide called sulfur trioxide. And this sulfur trioxide with water forms very well known sulfuric acid. Okay, so if you see here, acids are being formed. So we can say that non-metallic oxides are acidic in nature. Are acidic. So if you take the non-metallic oxides and test them with a blue litmus, they will turn red. So they are acidic in nature. They are not basic. That has been proved. Okay. So because when we dissolve these non-metallic oxides in water, they are giving the corresponding acids. So they are acidic in nature. So this was the first chemical property. Now let us see how the non-metals react with hydrogen. Reaction of non-metals with hydrogen. So non-metals will react with hydrogen and form their covalent hydrides. Covalent, now this is a type of bond known as covalent bond. you will be learning about this bond in carbon and compounds, okay, in detail. So till then, you know that they form covalent hydrides because they have this covalent bond. So non-metal plus hydrogen gives covalent hydride. So hydrogen reacts with sulfur to form hydrogen sulfide. So this is a covalent hydride. So it's a hydride of sulfur, covalent hydride of sulfur, but we are calling it as hydrogen sulfide. Then nitrogen reacts with hydrogen to form ammonia. Again, this is covalent hydride of nitrogen. Covalent hydride of nitrogen. And commonly we are calling it as ammonia. Okay, so this is the second reaction of non-metals with hydrogen, the second chemical property. Now, non-metals do not react with water or steam to evolve hydrogen gas. So you do not have any reaction like carbon plus water. No reaction. There will be no reaction. Nitrogen plus water. No reaction. Sulfur plus water. No reaction. Similarly, non-metals do not react with dilute acids also. So if you have here sulfur plus HCl, there is no reaction. They do not react, whether it is dilute or concentrated. Okay, so non-metals do not react with water or acids. Okay, now let's see the third chemical bond. How does a metal react with a non-metal? How do metals and non-metals react? What do they form? So many metals and non-metals, they will react and they will form ionic compounds. They form an ionic bond and an ionic compound is formed. Now, before we go to the ionic compound, let us see what are ions. Now, this ions topic you have already done in your grade 9. Let us just refresh. So, ion is, what is an ion? Ion is a charged atom. Yes, an atom which is charged. It has either positive charge or negative charge. Now, all ions can be either positive or negative. The positive ions are also known as cations, and the negative ions are also known as anions. Yes, positive and negative. This, you all have studied all this. Examples: Na plus, A plus, Ca2 plus. Anions will be chloride, fluoride, sulfide. Yes, and you've done nitride, phosphide. Then you also have done some compound ions like carbonate ion, bicarbonate ion. Then you have done is sulfate ion. So these are known as compound ions. You remember all this? So for you to refresh and again, go back to the ions, I'm sure you must have, as I've been telling you, even chemical reactions and equations, I told you go and read the chapter of atoms and molecules of grade 9. Yes, so that you know all the symbols and formulae and ions and all. So you must have already done it. So you already know now. Okay. You can always have that as a reference. So they are known as compound ions because they have two elements. They have here two elements. Yes, carbon and all. And here there is, so there are two elements in the ion, so then they are known as compound ions. Okay, so cation and anion. We know this. Now let us go and see how the ionic compound is formed. So for example, we take a compound like sodium chloride. This is an example of ionic compound. First, we will see how their ions are formed and why they are formed. So if we take sodium ion, sodium has, I will go and do it over here. Sodium configuration, atomic number is 11. So it is 281. Okay. So let us draw the electrons in the shell. This is the nucleus. Then we have the first shell, second shell. So first shell will have 1, 1 and 2. Second will have 1, 2, 3, 4, 5, 6, 7, 8. Now it has one more electron in the third shell. So it has 1. Okay. Now we all know, you all have learned that every atom wants to be very, 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 very stable. Now it can become stable if it has 8 electrons in the last shell. In the last shell of the atom, if there are 8 electrons, then the atom is stable. This is, we are talking about all the big atoms, whereas for the small atoms like hydrogen, helium, lithium, beryllium, it is only 2. If there are 2 electrons in the last shell, they are stable. Okay, 8 electrons is after that. From boron onwards, if they have 8 electrons, they are all very stable. So they try to get this magic number. I call this as the magic number. This magic number they require to actually become very, very stable. But if we see here, sodium has 1 extra electron. So it wants to quickly lose the electron and form an ion. Okay. Similarly, we will see for chlorine also. Chlorine is 17 atomic number. So 287 is the electronic configuration. Now let us draw. This is the nucleus. 2. Then we have the third shell. So first shell has 1, 2. Second will have 1, 2, 3, 4, 5, 6, 7, 8. Third has 1, 2, 3, 4, 5, 6, and 7. So now chlorine wants 1 electron to get the octet configuration. Sodium has 1 extra electron, so it wants to lose the extra electron, and this wants to gain the extra electron to become stable, to get the octet configuration. Octet. Yes, you are familiar with this word. Octet configuration is when an atom has 8 electrons in the last shell. It is known as octet configuration. Okay. So in order to get this configuration, sodium wants to lose the electron and chlorine wants to gain 1 electron. So what happens is sodium will lose the electron, 1 electron minus, and it forms Na plus. Plus it gives out this electron. It loses 1 electron and forms Na plus. Now why is it Na plus? It has lost an electron, isn't it? When it loses the electron, now if we see sodium, it is 2, 8. Yes, that means it has 11 protons, but only 10 electrons. So one of the electron here is less and 1 proton is more. So we put the positive charge, 1 positive charge. Okay, protons are positively charged. I know you all have done all this, but this is just for you all to do a recap and understand this topic better. Okay, so it forms Na plus plus electron minus. Now this electron, who wants to take this electron? Who is waiting? Whose desire is to get 1 electron? The chloride. The chlorine atom here wants 1 electron, wants to gain, saying, oh, give me 1 electron, I'll become stable. So what does it do? Chlorine, okay, plus 1 electron. It will take this 1 electron and form Cl minus. Now, why is this minus here? Because if we see here, this was 17. Now here it is, it has taken 1 electron, so it becomes 18 electrons, but the protons are only 17. So 1 electron is more, so we put the minus charge. Okay. So this is the chloride ion. Now what happens? We have two ions which are oppositely charged and chloride ions. So these ions, oppositely charged ions, they will attract each other. They attract each other and they form a bond. They will form a bond and a compound is formed which is sodium chloride. When you show the compound, you don't need to show the ions. That is, you don't need to show the positive and negative charges because they're already, as a compound, they become stable by this sharing of electrons. So what has happened here? Na plus Cl minus. So here they have attracted, because of the positive and negative charges, they attract each other and they formed the compound. So there was transfer of electrons from sodium to chlorine. So from sodium to chlorine, there was transfer of electron. Okay, and it forms sodium chloride compound. This type of compound, or the bond which is formed by transfer of electrons from one atom to another, transfer is complete transfer. Okay, it is totally, one is losing and the other is gaining electrons. So this type of transfer of electrons from one atom to another is known as the ionic bond. The bond which is formed is known as ionic bond. And these compounds, sodium chloride, which have an ionic bond, are known as ionic compounds. Okay. They have ionic bonds, number one, and they also have ionic ions in them. Okay, so this is how the complete ionic bond is formed. We'll see some more examples here and you will understand. Now, if we see, let's see what is ionic bond. Ionic bonds are formed because of transfer of electrons from a metal to a non-metal. It is generally from metals to non-metals because metals can lose electrons, non-metals can gain electrons. It can't be the other way around. Metals we have studied, they can lose electrons and non-metals gain electrons. Okay. So bond formed between positive and negative ions is called ionic bond. Even this is right. By the transfer of electrons, bond formed by the transfer of electrons between a metal and a non-metal. So ionic compounds are always formed. Ionic compounds are always formed between metal and non-metal. Okay, between a metal and non-metal. So what's happening here? If we see here, whatever we have studied now, sodium and chloride ion. So we can put it in the, so sodium has one extra electron. So let's put the extra electron as an X. And chlorine, we will show 1, 2, 3, 4, 5, 6, and then this one electron. Okay, one electron. So what is happening here? Sodium is transferring the electron to chlorine. So then this is step number 1. Second would be Na, and then we get, so the sodium has lost the electron. So chlorine now gets 1, 2, 3, 4, 5, 6, and here this. Okay, and it becomes minus. And finally it is NaCl. Because it is completely transferred, we give an arrow mark and then we'll write as NaCl. Okay, so this is the electronic diagram showing that there is transfer of electrons from sodium to chlorine. So this is how you need to show the formation of sodium chloride. How do you show formation of sodium chloride? You have to first draw the electrons around that atom. First write the symbols, then show the number of electrons in the last shell only. only in the last shell. Sodium has 1 electron. I put an X here in order to differentiate between the two ions. Okay. And we will show the transfer using an arrow mark. And then we show the ions. Then we show the complete transfer by an arrow mark. Okay. And then sodium chloride is formed. We'll see two more examples so that you will understand it better. How to show the formation of compounds. This is most important in this topic. This could be, your even 2 marks or 3 marks question. They may ask you show the formation of sodium chloride or aluminum bromide. So you should know how to do it. Okay. Now let's see. How do we represent the formation of magnesium chloride using the diagram? So magnesium. So first what do you do? Magnesium. It is 12. The atomic number. Again, chlorine is 17. So this is 2, 8, 2. So 2 electrons in the last shell. 17 is 2, 8, 7. Okay. Generally, they'll give you the atomic numbers, but it is better if you know the atomic numbers at least till 20. Okay, fine. So now magnesium, let's do the first step is magnesium. There are 2 electrons in the last shell. So we'll draw 2. Okay. Now for chlorine, there are 7 electrons in the last shell. So 1, 2, 3, 4, 5, 6, and 7. Okay. Now you will be wondering, if magnesium has to give these 2, then chlorine will have 9 electrons. So how is this compound going to be formed? You will be wondering, right? But what you do is, if you know, magnesium is, it is giving 1 electron each to 2 chlorine atoms, 2 chlorines. So take one more chlorine, 1, 2, 3, 4, 5, 6, and 7. Okay, now you see the transfer. 1 electron goes to this chlorine, the other electron will go to this chlorine, and you have here magnesium 2 plus. And here you have Cl 1, 2, 3, 4, 5, 6, 7, 8 minus, and Cl minus 4, 5, 6, 7, 8. Okay. So because there was the transfer, and finally we get magnesium chloride. This is the formula, isn't it, of magnesium chloride, MgCl2. So formation of MgCl2, when you see the 2 here, there are 2 chlorine atoms. So you cannot just use 1 chlorine and show the complete transfer, which is not possible at all. So 2 chlorine atoms, and then you come to the final formula of magnesium chloride. Similarly, now you'll be able to do this. I'm very sure. Aluminum bromide. Sometimes they may just give you the name. You have to use and write the formula and then show the formation. Okay, here I have shown you giving the formula. So aluminium we will take is 13. So 2, 8, 3. And again we have bromine would be, the last would be 2, 8, 7 because they belong to the same group. Okay, so 2, 8, and 7. Now here we have 3 bromine atoms because there are 3 electrons. So aluminium, if I take 1, 2, 3. Now I'll take bromine, bromine, and bromine. So here I have 1, 2, 3, 4, 5, 6, 7. 1, 2, 3, 4, 5, 6, 7. 1, 2, 3, 4, 5, 6, and 7. So now each of the aluminium electron will go to 1 each to the bromine. So now we have aluminium, and we have here Br, Br, and Br. Okay, so we have here, and finally formation of aluminium bromide, AlBr. Okay, so this way you have to show the formation of ionic bonds. So all these are ionic compounds because they have been formed by the transfer of electrons between a metal and a non-metal, between a metal and non-metal, between a metal and a non-metal. So this is what you need to know. Number one is you should know that ionic bond is always formed between a metal and a non-metal. Secondly, ionic bond is formed by the complete transfer of electrons from the metal to the non-metal. So metals, they will form positive ions, non-metals will form negative ions. They attract each other and then they form the ionic compound. When you're showing the formation of the said compound or the given compound, what you need to do is you write the atoms and then you write their electronic configuration, show the electrons in the diagram, the number of electrons in the last shell of the atom, and then show this transfer by arrow marks. Okay, so this is how you need to show the ionic compound. Now let's see what are the properties of an ionic compound. They have very interesting properties, ionic compounds. So they have high melting and boiling points. So if you see all these compounds, sodium chloride, potassium chloride, sodium bromide, okay, then we have seen aluminium bromide. All these have magnesium chloride. They have very high, they're all ionic compounds, they have very high melting and boiling points. Why do we have high melting and boiling points? Because the bond which is formed between two ions, two oppositely charged ions, and a lot of energy will be required to break those bonds. Okay, a lot of energy is required to break those bonds, so they have high melting and boiling points. Okay, most of them are crystalline solids at room temperature. At room temperature, if you take they are mostly salts. Yes, salts are all crystalline, so they are crystalline solids at room temperature. Then they have a regular geometric pattern, which is a crystal lattice. It is called as a crystal lattice. These are the crystal lattices. That's the reason they're good conductors of electricity, but not in the solid state. They have to be either dissolved in water or they have to be at least melted, molten state. In the molten state, they will conduct electricity. Okay. Then they are hard and brittle. They're hard if you take, salt and all, but then they're powdery also, brittle very easily. Even if you take lumps of the salt, it can be broken easily, isn't it? It becomes like a powder. If you just do it this way between your fingers also, you mash it between the fingers, then the lumps gets into a powder. Then they conduct electricity in the molten or dissolved state only. So they're very good electrolytes. They can conduct electricity. Why do they conduct electricity? Again, because they have ions. But, very important, they conduct only in the molten. They should be melted or they should be dissolved in water. But otherwise, in the solid state, if I take just solid sodium chloride salt and I connect it with the wires and expect it to conduct electricity, it is not going to, but it has to be melted. Okay, so these are the properties of the ionic compounds. So now here we have again a self-check assessment for you. I'm very sure you will now be able to answer all these questions once you have understood the concept of the ionic bonds and the physical and chemical properties of nonmetals. So I request you to please do it seriously. Yes? Okay. So what have you learned? You've learned about the physical properties of nonmetals, chemical properties of nonmetals. Then we've done about the ionic bond formation. And then we have taken 2-3 examples also. And then we have also done about the properties of ionic compounds. Yes. So you should know how to show the formation of any ionic compound. You should know what is an ionic bond. Then you should also know the properties of ionic bonds. So read the chapter metals and nonmetals from page number 46 to 49. So it will cover all the topics which we have done now. And practice the equations of the chemical properties. Again, I insist that you always practice by writing, because that is the best way you can register, remember, and reproduce it in the examination or in assessments, right? So we will be doing about metallurgy in the next topic, and which is again very, very interesting, which is about all about extraction of metals from their ores. So till then, I leave you with a wonderful fact. So read it, enjoy it, and keep learning, and enjoy your journey till we again to the next topic, which would be the last topic of our destination before we reach our destination of metals and non-metals. So till then, this is Usha Mangipudi signing